We're doing the radix sort, and to do this we need to come up with an unsorted array of numbers. It's an integer array that we're going to be using, so our output will look something like this up here. We first need to sort in ascending, which is what the first output is. We sort it in ascending, and then we need to sort in descending, and that's after we reset the array to its original order and then sort it again. So this will be our output, the future output, and that's only after we code it. So those are those instructions. We also have this Google Docs that provide more instructions, and the link for this will be in the description below the like button. Just a quick overview, this is what it will look like. So knowing this, we need 4 classes right here. We need a driver class, which I have as main. We can refactor this by making it make it a driver. So we'll go rename, and I'll just call it driver, and then we'll update all references and click finish. And so now it's a driver class. Then we need no, queue, and radix classes. So we're going to do this all in one Java file. We are going to have public, we're going to have node, and then we are going to come below that. We are going to have, or I'm sorry, that shouldn't be public node, that should be class node. We're then going to have a class queue, and then lastly we are going to have our class, and then it's going to be radix for our radix sort. So those are our 3 classes. Now we have more instructions here. This is pretty important. We're going to be using static methods inside of our radix class, so we don't have to make an instance of our object. Of our class. We don't need to make an instance of our class. We're just going to make everything inside of it static. And then there are some general rules that we need to follow, and so on and so forth. So now we are going to look at the actual code for this. We're going to start off with our main method. There's a few things that we need to do inside of here. First thing that we're going to do is make our array, and we're going to be hard coding our array. This means that we're not taking any user input or anything, so we're just going to have int arr for array, and then we're going to set this equal to, we're going to have these braces, and then inside of here we're going to have random numbers that we're going to use. These can be any kinds of numbers, so just have a good bunch so that we can compare them, and you can write them in like this. So this is our array of numbers that we're going to use, and now we can copy into our array. So inside of our radix class, we are going to need to have a copy method. And the reason why we need a copy method is because per the instructions, we need to reset our array after we write it in ascending order. So to copy this, we will write out copying array, and then we will make our copy. So we will do int, and we will just call this arr copy, and then we will set this equal to a radix dot copy. And then inside of here, we want to pass in our arr and also our arr dot length. And so this will give us the entire array and the length. So we can highlight over this, and we can create the method inside of here. It's public static int copy, and then we pass an int arr. This is a array, and we're returning an array. Then we have an int length inside of here. So in here, we're going to rewrite this, and then we can code this. So for the copy, all we're doing is we're rewriting our array. We're going to make a new array that we're going to return. We'll just call it temp. We'll do int, we'll have the array symbol, call it temp. We're setting it equal to new int, and then inside of here, we are going to have our array size. And that's because we want this array to be the same value as the array we're passing in. So we're going to have length inside of here, and we're going to come outside of here. Then we're just going to be in a for loop, and then inside of our for loop, we'll just do int a is equal to 0, and we're going to run a as long as it is less than length. And then we're just going to do a plus plus, and then outside of here, we will be inside of our for loop, and we'll just do int, and then, or I'm sorry, not int, because we don't want to make a new array. We'll do temp, and then inside of here, we'll do a, and then we're going to set this equal to our arr a. So this will basically copy whatever is in our array at this position to whatever is in, or whatever we need it to be for our temp. And then once we're done with all of this, we're going to break out our for loop, and then we're just going to return temp. And so now our ARR copy inside of the main method will have the temp inside of it. So that's for copying the array. The next thing that we need to set up is when we get the max number for our indexes. So we're going to use a method, and we're going to call this. So we're going to write getting the max number of indexes. And the theory for Radix sort is linked below the like button in the playlist, chapter 4. You can do a control F and just look for Radix. And that's like how we would go about thinking about it. So getting the max number of indexes in here, what we're going to do is we're going to do int, and we're going to call it max base. And then we'll make a new method inside of our Radix class, and we will do radix.get max length. And then inside of here, we're going to pass in our ARR and also our ARR.length again. So we can hover over get max length. We can click create new method, and this will create a new method for us. And so this is our new get max length. So inside of our get max length, what we're going to write is code to get the actual base, the digits in our base. And since we're dealing with the base, instead of length, we will call this base. So get max base. We're really getting the max base length. So inside of here, we're just going to set int max equal to the first array value. That way we're just initializing it, and we're not wasting any space. And then after we do this, we are going to find the max value in the array. So inside of here, we will have a for loop. That way we can run through every single value in our array. We're going to do int a is equal to 1. And the reason why we're doing a is equal to 1 is because we've already looked at the first value right here. We're going to run this as long as a is less than length, and then we're going to do a++. And then outside of here, we are just going to compare. So we're going to do if our max value is less than the array index method, or the array index element that we are currently looking at, we are going to set max equal to that array index element. And that's what that's going to look like. Once we've done with this, we can come down here, and now max stores the longest integer inside of max that was in our array. And so what we can do is we need to now get the base of it. So getting the base, we are going to initially set int max base equal to 1. And we're going to assume that we have at least something inside of here. And so if we have 5, right, then the max base is 1. If 5 was the biggest number, if anything from 0 to 9 was the biggest number, the max base will be 1. So inside of here, after that, we're going to write getting the largest base. And this is what this for loop is for. So we're going to do for, we're going to do int I is equal to max. And we are going to kind of deteriorate this value until we get to the very end of it. So we're going to run this as long as I is greater than 1. So we have I is greater than 1, and I is some arbitrary value. I usually do like a, so we can change this to a if we wanted to. So this is any value. Int a is equal to max, and so max is the max value here. And then we're running this as long as our basically max value is greater than 1, and we're doing the a is equal to max because we don't really want to touch the max itself. And then after we do this, we are just going to do a divided by 10. In this way, we can look at each base value. So if we had something like 1, 2, 3, comma 4, 5, 6, the first 10, we'd be looking at this 6, and then we'd be looking at 5, 6, 4, 5, 6, 3, 4, 5, 6, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. So now we can go inside of our for, and this should be a divided by equals. And so the divided by equals means we're basically saying a is equal to a divided by 10. And then inside of our for loop, we are going to set our max base equal to the max base times 10. And then outside of our for loop, below it, we are going to set our max base equal to the max base, and then we're going to divide it by 10. That way we can, like I said, deteriorate through it over time and look at all of the different values, because 1, 2, 3, 4, 5, 6, we want to see the base of this. So we would look at this, and then, well, we would take this out, and this, and so on and so forth, until we get the largest base value. And if we have this 1, 2, 3, 4, 5, 6, we would see that our longest is 6. We have 6 digits in here. And then after we're done with all this, we're outside of this for loop. We're going to come underneath this max base right here, and then we're going to return the max base. We'll write more about that up here, so we'll do just a comment like this, then we'll move this over here. And so in here, we are getting the max base, which is the number of digits for our largest integer. Our parameter is the array that holds our values, and then the length that we're passing in is the length of the array, and then what we're returning is the number of digits for the largest integer. And so those are our Java doc written out. We can do the same for our copy method as well. And so we have the setup for our initial code done. We have the driver class written out, we have our copy, and our get max base. From here, afterwards, we are just going to finish setting up the node class. We are going to set up the queue class as well. It's important to note that this is all leading up to sorting the array in ascending order, and then resetting the array, and then also sorting the array in descending order. We can actually reset the array right now. After we do the array in ascending order, we're just going to set ARR equal to ARR copy. And so that will reset our array. Now we're going to deal with the ascending and descending. In dealing with these, we are going to have to build our node class. And the node class is really a helper for the queue class, because what we're doing with the queue is we are making kind of buckets, and that's explained more in the actual Radix kind of thought process. But queues are used to make buckets for storing values in and then sorting them, and then nodes are used to make the queues. So next we're going to be working on nodes. Now, looking at our node class, we're not going to use much. We're not going to get any values that are nodes or anything. So in like previous lab, we use getters and setter. We're not going to be really interacting with this node class at all. So what we can do is make a private int data. We are going to make a private node next, and these will basically store the data and the next value. And then we're going to make a constructor so that we can access them, and our constructor is going to be public. We're going to do public node, and then we're going to have inside of here just the data, because all we want to do is add to our nodes into our list of nodes. So this is kind of like a list node. We have data, then we have the next value, the next value, and the next value, and we just want to access the data value itself. So we're just going to have in here this dot data is equal to data. And so that's it for our node class. We can now look at the queue class, which is going to use the node class. So inside of here, we are going to need to make a head and tail value. And the reason why we need to make a head and tail value is because we need to be able to add and remove things from our queue. When we add things to our queue, we add it to the tail. When we remove things, we remove it from the head, unless special cases where the list is like empty or we only have one value. So starting off in here, all we need is to see if our queue is empty, because we're going to use that in the Radix. And then we also need to see if we can, or we need to code an enqueue and dequeue, which is basically an add and remove method. These aren't going to be static because we're going to make an instance of this class in our Radix class. So we won't have any static modifiers here in the functions. So we have this class queue. We're starting out. We're going to have a node head, and then we're also going to have a private, I'm going to see if I can do this all in one line, tail. Let's see if that works. it does work. So we have a private node head and private node tail. We want to check if it's empty or not, so we need a Boolean method for it. We're going to do public Boolean is empty, and then inside of here we will check if it's empty or not. And so we're just going to return if head is equal to null. And if head is equal to null, that means our list is empty, and so we would return true. It is empty. Otherwise, we would return false. So just commenting this, we are just returning if head is empty. Now we can work on our add or enqueue method. So we're going to come down here. We are going to do a public void, and we'll just call this enqueue. And then we're going to pass in some data value because this is the value that we want to add. Now, inside of here, there are a couple of different cases that we can look at. So the first case that we can look at is if we have an empty head, if our list is empty. Before we do that though, we should create a new node. So creating our new node, we're going to say node is equal to, or we're going to call it node, and we'll set this equal to a new node. And this is basically making an instance of this node class so we're able to use it. We do need to pass in a value because we have this public constructor right here that's asking for a value. We don't have an empty one or a general one. So we're going to just pass in data, and this is this data right here. We're adding it to the node. So we can say, well, if the head is empty, we will point head to tail. So if our head is empty, we're going to say that head is equal to null, and we're going to say that head is equal to the node since it's being the only thing added in there. And then we also have to set tail equal to node. So we will do if head is equal to null, then we're going to come down here and we're going to say, well, our head must equal the new node. And then also that our tail has to equal the node. We're going to be in an else statement, an else if statement. We're going to say if the tail is not empty, meaning that our list is not empty, because, well, if we have one thing in our list, like right here we have one thing in our list, then the head and tail point to something. That means our tail is not empty. So if tail is not empty, the value after the current tail is, we'll say, our new node. And so we can come down here and we can say else if our tail does not equal null. We're going to be inside of here, and then we're just going to say, well, our tail dot next, the next value in here, has to equal to our node we're passing in. And then also, it seems like we can't make the next value private. Otherwise, we would need like a getter to get this. But we can just make it public. We won't write out a getter. So we'll just have a public node next instead of a private. So we have this else if inside of here. And, well, we also need to set the tail equal to node. Well, since both of these require that the tail be set to node, what we can do is just take it out of here, and we can write it down here and say that tail is equal to node. Since whichever one of these happen, the tail is going to have to equal to node. Now, what we can do is we can actually write out some commentation for this. So we can say this adds to our queue. And so we are basically enqueuing something. We're adding it to our queue. And then we have our parameter, and this data is being added to the queue. And now that that's done, we can come down below it, and we are going to write our dequeue, which is basically the remove method. So in here, we have public void dequeue, and we aren't going to be passing anything in. We're just going to be calling this to remove something. So in our dequeue, I'll leave it right here, we are going to return the data since it now stores the head. Remember, dequeue, it returns data, it returns whatever the head is, and then it sets the head to the next value. So what we're going to have to do is say that our int data, this is what we're returning, and this should be an int instead of a void because we are returning something. We are going to be in fact returning data. So we're going to say int data is equal to head dot data, and this will give us the data value at our head. And just like our node, this has to be public or we have to have a getter for it. So instead of making a getter, we'll just make this a public instead. So all of this is public, no privates in here. And so we have a return data that we can do. Before we return the data though, we got to make our previous next value be the new head. What happened to the recording, but looking back at this, we made this DQ, actually we should be at the DQ, and basically we are returning the data since it is now stored in the head. We want to DQ something, so that's removing it from the front and returning it. So we're returning this int data. We set data equal to head.q or head.data. We're returning the data here, and then we're setting the new head to the next value. So head is equal to head.next. This gets the next. And then if our tail node, which is the next value, which is now the head, is null, then well, we have to say if head is equal to null, that means our tail is null. Because if head has nothing in it, our tail has nothing in it. So we have to rearrange the tail pointer. We're going to need to make a sort for our ascending, which we would print out here, and then a sort for our descending. We're also going to need to actually print these out. So what we can do is make a private method in our Radix class, which will be like a toString, and it'll print this out as a string. And then we are going to need another helper method, but we'll get to that in a second. So for ascending order, what we can do is say, well, we're going to want to print something. We're just going to do a sysout. So this is going to be void. We don't need to store it in anything. All we need to do is radix, and then we're going to do dot, and then we're going to say sort A for ascending. So we have sort A, and then we're going to pass in our array, and then we're going to pass in our max base. So we're going to do int arr, and then we're going to also pass in the max base. And then we can come outside of here and end this line. We're going to do the same thing for the sort in descending order. Remember, because for descending, all we're doing is we're going to take what we have here. The only difference is that we are going to be printing it in the opposite order. So we'll just change that little bit in our code. So we have these two written out, and we can hover over it. We'll create a sort A method, and then we can create a sort D method. And then I just realized we don't need to pass in the type when we're pushing parameters into these methods. So we can come down here and we can see that it is implemented right here. Since this happened afterwards, I'm going to cut this and I'll bring it below right here. So we have our sort A, well, we have our sort D and sort A, but we'll just rearrange them so it's in order. So we have sort A, and then we have sort D. So for sort A, we're going to print out our prompt first. We're just going to have a sysout, and then we are going to in here write radix in radix sort in ascending order. So this is going to be our string, the prompt kind of. And then after this is where we're going to use the queue. So we are creating a queue for 10 buckets because a radix is from 0 to 9. So we have queue, we have these brackets, and we have our array here. And this bracket is basically saying, well, we're going to make a new queue, and we're passing in 10 indexes in here. And then after this, we're going to add our buckets. So we're going to write adding buckets 0 through 9 into the queue. Because above this, we've only made a queue. We haven't put anything inside of it. We've made 10 queues, but we don't have anything inside of it. So inside of here, we're just going to have a for loop that'll go 10 times. We're going to say int a is equal to 0. We need to start a at 0 because, well, we're looking at indexes. And we're starting at the first part. And we're going to do a++. And then inside of here, we're going to do a queue array. And then we're going to set this equal to, actually, we're not going to set it equal. We need to get the position of our queue, and we're going to set it equal to a new queue. So when this runs, zeroth time, we're making a zeroth one, and then we're making a 1, 1, 2, 3, 4, 5, 6, 7, 8, until we hit 9, and that will take up all of the queues in our queue. And so that will be that. Now what we're going to want to do is filling the buckets. We're going through the powers of 10. And so we're going to do this with a for loop. We're going to say for, and then we're going to have an int. We're just going to write power of 10. It's pretty fitting. We're going to set it equal to 1 first, and that's because, well, we're going to start off with 1. We're going to say this is going to run as long as power of 10 is less than or equal to our max base, because we don't want to go over this. We just want to be less than, but also we can be equal to. Actually, we want to be equal to, basically. We want to run this entire for loop as long as this is less than our max base, and then we're going to stop it at the max base, but run it while it's equal to our max base. And then we're going to say power of 10, and we're not going to do plus plus here, we're just going to do times equals. And so basically we're saying power of 10 is equal to power of 10 times 10, because, well, it's the power of 10. And then we're going to be inside of this for loop. Inside of this for loop, we're going to be examining the values in the array. So in examining the values, well, we need to examine all of them. And so we're going to run this for loop for int a is equal to 0, and then we're going to do a is less than array.length, because we want to run this the entire time. And actually, I just realized that for our sort A and our sort B, it says we're passing in an object, but I meant to be passing in this integer. And so I guess the problem is that instead of just passing in ARR, we can't do that. Well, we can. The problem is that when Eclipse, because we hovered over it and we made it auto-generate a function, Eclipse thought of it as an object. So this needs to be an int, and we'll just say that this is ARR. And then the same thing for this. I guess that's really good to catch, because sometimes Eclipse in their auto-generation might make a mistake there. So now that these are both ints, we can compare these properly. We're going to do ARR.length, and so we're going to run this as long as it's less than length, and we're going to do a++. And then we're going to be inside of our for loop. And then inside of our for loop, there's a few things that, well, we're actually going to be only in this for loop for a second, and then we're going to break out of it, go back to this outer for loop, and then we're going to write below it. So inside of this for loop, we're going to be queuing into the array whatever digit we currently have. So inside of here, we have int digit, and this is equal to get digit. And so inside of here, we're going to have our array, and then we're also going to be passing in our power of 10. And this will become familiar with Radix sort, because when we make a queue, we have to make it for the first power of 10, and that's why this is the outermost for loop, because we're doing it one time, and then we're going to sort everything to that first base. And then we run this again, and then it's the second base. So it's going to be the second slot. So if we have like 1, 2, 3, comma 4, 5, 6, first time this goes through, we're sorting this with this last digit in mind. Then the next base has this last 56 digit in mind, and then the next one has this 456 in mind, and then so on and so forth, and that will help us sort it. So that's what this is going to do. We are going to have to create a method for this. I didn't mean to write ARR here as well. So we're going to hover over this, and we're going to click create method, get digit, and this will make us our method. So what we can do, since we were actually going to use this for our sort D and our sort A, since we are using it for the sort A, we can paste it down here. It's private because we're only using it in our sort A and our sort D, and so we can now write inside of here. all we're going to be doing is returning the number divided by the power of 10 that we're passing in and take the modulus of it. This will give us whatever kind of quote unquote remainder that we have. So we'll just say, well, we have our number, which is I, because it auto-generated it as I. So we'll just go with it. We're dividing this by the power of 10, and then we are going to take the modulus of this result, 10. And we're just going to return that. And so if we had like 1, 2, 3, 4, 5, 6 again, if we have 1 as the power right here, well, we're going to do I divided by 1. So we're going to get 1, 2, 3, 4, 5, 6. The modulus of this is 6. So we're going to sort it in the 6th queue. Next, we do this again. The power of 10 is 10. And then we have 1, 2, 3, 4, 5, 6 divided by 10. The modulus of this will be this 56. And then so on and so forth. So we can see how that would get more sorted as we go. So inside of here, we're going to need to store this in a queue. And this queue is this one. Now we're going to go back inside of here, and we're going to add these values to the queue. And so what we're going to do is we're going to have queue array, and then we're going to have the index of whatever our digit is, and then we're going to dot enqueue. This will add it to our queue, because remember, enqueue is adding. And then I don't know why there's an A here, must have mistyped, but we should have an array of whatever A we're currently looking at. And I think this array should be ARR. So we have this int digit, and it's equal. I don't know why there's a brackets here either, or braces, but we should have this int digit, here we go, is equal to get digit, and we're passing these parameters. This will call this method and get the digit there. And then we're going to say that the queue array, we have this digit, whatever digit we have, and then we're going to enqueue this into that array. So this creates the queue, this creates the buckets in our queue, the queue and queues, and then we are going to be basically filling our buckets with this for loop, and then this for loop, because this outer for loop is basically running for every single base that we have, every to the power of 10 that we have. And then we have this for loop, which is going to examine all of the values, and it's going to enqueue them inside of here. And then after we do this, we are going to break out of this loop. So we'll come down beneath it. We're going to make an integer, int item is equal to 0, and this will become clear in a second. And then from here, what we're going to do is we're going to have another for loop, and then we're going to do ints, and then to be specific, we'll call this queue number, and we'll set this equal to 0, and this is the queue num that we're looking at. So the queue number is less than 10, because 10 is how many queues we have, because this is going from 0 to 9, so the length is 10. And then we're going to say, well, we have queue num plus plus. And then we're going to be in these braces. And then inside of here, we're going to have another for loop. We're looking at this item part right here. So we're just going to block this off since we've already declared it. And then we're going to run this as long as our queue array is not empty, which is where the is not empty came in, where we created that earlier. We're going to have, well, queue array. We're going to look at the queue num index, and this is running as long as it is dot not empty. So we're going to say dot is empty, if I can spell that correctly. If that's spelled wrong, and then I think that was spelled wrong. So then we can have our dot is empty, and then we're just going to do item plus plus. And then we're going to be inside of our for loop, and inside of our for loop, what we're going to do is realize that I thought I said queue num. I guess I must have miscorrected that when I tried to correct that. Inside of our for loop, we are going to have the array ARR. We are going to have the item, and this item, remember we declared it up here, is equal to, and then we are going to have queue array dot, and then we are going to have, or not queue array, sorry, we're going to have queue array, and then we want to get the actual index of what we're looking at. So we're going to do QArray. We are going to do QNum, because this is the outer index we're looking at. Because remember, we're basically pulling everything out of our bucket now, and we are putting it in here. And so QNum, and then we're going to do dot dequeue. So this will remove it from our queue, and that's it. We've dequeued it. And so that is going to be the dequeuing. And so that kind of like sorts it back into the array here. And we'll go over that when we do it in the sort D, because it's very similar. But this is how we would write out sort A. And sort D, the only difference is the last part. The last part is because we're doing this in reverse. But going over the sort A, we have this radix sort in ascending order. We have this queue, which will create the queue for the 10 buckets. We are going to add bucket 0 to 9 for the queue, and so this is a constant time. We are then going to fill the buckets, and this all happens in here. And so we're going to run through this as long as our max base has max in it. Once that maxes out, we're going to break out of this for loop, but inside of here, we're going to examine the values in our array. We are going to get the digit of each value, and then we're going to enqueue it into our queue based on the digit of the queue, based on the digit of the value at that index. And then we're going to have int item, and then we're basically going to be pushing this back into our array so that we can look at this all over again. Once we have all that done, all we got to do is print it. So we need to make our toString method, and that will be done in the next part with sort D. In the previous video, we did sort A. Now we didn't finish it. We need to do the toString method for it, but we're also going to do sort D in here and attempt to run it. We're going to come down here, and down here we'll make our toString. So we are going to do a private again, because this is a private method. We're going to have it be static because, well, we're just accessing it, we're not making an instance of it. So private static, it's going to be a void because it's just printing. Then we're just going to call it toString. We want to pass in just our array, and that's all we need. So we're going to have this, and then this is going to be our method. If we hover over this, well, first I need to finish writing out the array. Then there's no more errors. So we fixed it, it was just missing the array. Inside of here, we are going to do a for loop that will run the entire length of our array. So we will do for, we'll do int a is equal to 0, this is arbitrary, we'll do a is less than arr dot length, and then we're going to do a plus plus, and then we're going to be inside of this for loop, and then we're just going to do a sysout, and then we are going to realize that I am new to this MacBook Pro and cannot figure out the keys, and then I figured it out. So we have system.out.println, and then what we want to do is print out the specific index. So we have arr a, and then we want to fix this up a little bit, but we'll get to that in a second. We're going to add some commas and braces to make it look nice. If we just look at this, if we get rid of this print line and then do a sysout print line for the outside of this loop, because we want to print a line down here, but we don't want to necessarily print a line in front of every single thing. So we'll have this, and we have our radix sort in here. All we need to do is have a toString call in here where we pass in the array, and then we can try to run it. So if we run this, we get radix sort, and we have a bunch of numbers. Okay, so to see this, we are definitely going to need to add at least a space for now. We can run it again, and we get 5, 6, 9, 88, 96, 234, all of the rest, and that looks like it's in order. So that looks good. Let's come down here and fix her up a little bit. So what we want to do is we're going to do a sysout, and we're going to always print out braces no matter what. So we'll just have a brace in here. We'll have a space. That'll print out the first one. Now we can run this for our array.length -1. That way we can add a comma in here, and then at the end it won't just print out a random comma. because after our for loop, we are going to come down here and we are going to print out the last one with our last bracket. However, we only want to print out whatever is last if there's something there. So we're going to have an if statement. We're going to do if our array, our arr.length does not equal 0, we will be inside of here. And then we can say, well, we want to print, we'll do a sysout, and then we are just going to have our arr, and we want the element at this index, so we'll do arr.length -1 because we want the index, not the full length, because the length is one more than the number of indexes. And so we have this in here, and then, well, we can just, since we have a print line in here, we are going to append to this our closing brace. Otherwise, we're just going to come down here and print out a closing brace. And just to make sure we don't print out two braces, we're going to surround this with an else. And so now we can run it and see if it looks good. Running it, it almost looks good. Just gotta take out this print line right here and make it a print. And we ran it and it looks nice. So now we can move on to sort D, which is sort descending. Very similar to sort ascending. We're going to have a sysout and we're going to write out radix sort in descending order. And then we're going to come down below it. We're going to do the same thing where we create a queue for 10 buckets. So we're going to do queue, the brackets that indicate that we are having a specific number. Then we're going to do queue radix, or I'm sorry, not queue radix, we'll do queue array, and this is equal to a new queue, and then we are making it as 10. So inside of here, we're going to add the buckets 0 through 9 to the queue. We're going to use our for loop again. It's going to be int a is equal to 0. I'm running this as long as a is less than 10. And we're going to have a plus plus. And then inside of here, we're going to have queue array. We're going to have a, and this is equal to a new queue. And so, well, we've made our new queues. All we got to do now is, as we've done previously, fill buckets going through the powers of 10. So we have a for loop in here. We have int power of 10. Remember, this is very similar. This is starting at 1. And then we're running this as long as power of 10 is less than or equal to our max base, because we want to examine everything until we hit the max base. Once we hit the max base, the way that radix sort works, everything will be sorted. And for more information about how radix sort works, it'll be in the playlist link below the like button. You can just do a Control F and find it in there. And lastly, we are going to want to increment our power of 10. We're going to do power of 10 times equals 10. And then we're going to come out here, and now we can start writing our for loop. So we're going to examine the values in the array. We're going to have a for loop. We're going to do int a is equal to 0, and then we're going to do a is less than our arr, which is the array, dot length, because remember, we are examining all the values that are currently in the array we're passing in. We want to increment this, so we're just going to do a plus plus, and then we can come outside here, and then, or we're actually going to be inside of here, and then we're going to be queuing into the array whatever digit we have. So this is like what we did last time. We're going to find this digit and we're going to set it equal to digit. So we're going to do int digit, and this is equal to the get digit. We're going to be revisiting our private function down here again. And then we're going to pass in our array at the specific index, so array A, and then we're going to pass in our current power of 10. And so from here, we're going to write a queue array, and then we have our digit has the index, and then we're going to do dot in queue, so we're adding this to the queue, and then we're going to have our arr at the index A. Now we're going to come down below this, and we're going to do a int item is equal to 0. This is where we change a little bit. Instead of writing what we wrote up here, where we were ascending, we want to be descending. So we are going to be decrementing. And that's kind of wordplay. Ascending is with we're incrementing. Kind of sounds familiar, but you can really get it when you say you're descending, it's decrementing. So we have 9 is the max queue size. It's important to keep in mind when we write this for loop, we're going to have 4. We're going to do int q num. Instead of being equal to 0, it's equal to 9. And then we're going to run this as long as q num is greater than or equal to 0. And then we're just going to do q num minus minus. And then we'll be inside of our for loop. And then I guess I just did plus equals. I meant to do less than equals or greater than equals. So running this as long as q is greater than or equal to 0. Or you could say as long as 0 is less than or equal to our q num. So inside of here, we're going to have another for loop. We're going to do the for, and then we're going to run it. So we've already declared the item. We got to have this in here. We're going to run it as long as q is not empty. So q array, have the exclamation mark out front. Q num, so we're getting the specific index that we are looking at for this array. Then we're going to hop out of here and we're going to do dot is empty. So as long as it's not empty, and then we're just going to do item plus plus. And then outside of here, we're going to do array. We're going to get the specific item index. So we're going to do item, or I'm sorry, we're using item as our index. And then we're going to set this equal to the q array. And then inside of here, we are going to have the index, which is q num, and then we're going to do dot dq. And so we are dequeuing. This should be ARR also, and then this can be over here. And so this should be our dequeue. All we got to do is print it. So we're going to call the toString again, and then we're going to pass in our ARR, and then we're going to close that off. Now we can run it. It looks like this. We can check to make sure it's all good. It looks like it worked. So that is the Radix sort using small main method, which is nice. We have our node class, which is really a helper for this queue, and in our queue we have the private node head tail, we have isEmpty method, we have an enqueue function, we also have a dequeue function, which I will write some comments for real quick. And lastly, we have the Radix sort class, which is really the heart of this. So first we have these kind of copy and get max base, which really introduce us here. And then we have sort A, which really throws us into Radix sort. And then we have sort D, which is another thrust into Radix sort. And then lastly, we have these two private fields that will, or private methods, sorry, not fields, methods or functions. And this will help us write the actual sorting. And that's the entire code and output for this Radix sort lab. Important to mention that I realize I just have a bad habit of, but classes should not start with an uppercase. So that should be lowercase. This should also be a lowercase. And so we're going to have to change all of these, or at least I'm going to. So these should be node. This should be node with a lowercase. Again, because that class name should be a lowercase. So that should be a lowercase as well, meaning that this should be a lowercase, this should be a lowercase, this, and this should all be lowercase. And then we're going to have to come down here to the queue. And we're going to change all of these to lowercase. And then we're going to come down here and we have to lastly change in our sort D to lowercase. And after we do that, then all of our errors should be done. We'll run it again just to make sure all is well. All is well, all is good, and now it works, but it works even better because it is correct.